Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's session, we are going to discuss an overview of D'Alembert's principle. Okay, let's go to the topic. What is D'Alembert's principle? It states if a body is acted upon by a system of forces, this system may be reduced to a single resultant force whose magnitude, direction, and the line of action may be found out by the method of graphic statics. Simply, we can say summation of external forces that equal to the inertia force. Okay, inertia force, numerically this equal to the product of mass and acceleration. Okay, and then this inertia force will act always opposite to the direction of motion. Okay, for the different types of cases, we are going to discuss the D'Alembert's principle. Okay, first, motion of an object on a rough horizontal plane. Okay, here also two cases we are going to discuss. Either the object moves towards right side or towards left side. Okay, first case A. Here the object moves towards right side under the action of an applied force. Okay, so for this case, we are going to consider the D'Alembert's principle. Okay, consider an object is lying on a rough horizontal plane. Okay, if you consider M is the mass of this object, the weight, that is mg. Okay, the weight mg, that will act exactly vertically downward. Okay, that means this mg, that is weight of the object, is the force exerted by the object to the plane. Then the surface that will exert equal and opposite force to this weight. Okay, that will act exactly upward. Okay, that is reaction force. Okay, these two forces will act when the object is not in motion, even not in motion, when it just lies on the surface. Okay, now under the action of an applied force. Okay, here when an external force is applied towards right side. Okay, an external force is applied towards right side. The desire is to move the object towards right side. Okay, due to the external force towards left side, that is opposite to the direction, the frictional force will arise. Okay, Ff, which is equal to mu, the coefficient of friction between the sliding surface and then object, multiplied with the normal reaction. Okay, when this external force overcome the frictional force, then the direction of motion of the object, that will be towards right side. Okay, direction of motion, that will be towards right side. That means we can say when the applied force overcome the frictional force, the object will move towards right side. Now, the summation of the external forces here, F, that is acting towards right side, F, the frictional force that is acting towards left side. Okay, so the resultant force on the right side, capital F minus this capital F suffix F. Okay, that is the summation of the external forces. Okay, that equal to the inertia force, which is equal to the mass multiplied with the acceleration, that will act always opposite to the direction of motion. That means the inertia force that will act opposite to the direction of motion, that is mass into acceleration. Okay, this is the inertia force. Okay, so we can say, as per the equilibrium principle, summation of vertical equal to 0. So we can write the normal reaction R that equal to mg. Then summation of horizontal forces equal to 0. Right side force F minus FF. Okay. This is the summation or algebraic sum of the external forces that equal to the inertia force mass into acceleration. Okay. And here you can see FF, that is the frictional force, which is equal to the product of coefficient of friction multiplied with the normal reaction. If you substitute this value here, we can write capital F minus mu R that equal to MA. Okay. So this is the analysis of D'Alembert's principle when the object moves towards right side under the action of an applied force. Here, in case if the object moves on a over a smooth surface, okay, if it moves over the smooth surface, then mu equal 0, and hence the force of friction, frictional force, that will be 0. So in the previous equation, F minus mu R that equal to MA. Okay. So here, this term will be eliminated. So we can write F equal MA, or otherwise F minus MA equal to 0. Okay. This is the analysis of D'Alembert's principle of the object moves over a smooth surface. Okay. Case B, object moves towards left side under the action of an applied force. Okay. So here, as usual, consider an object lies over a rough horizontal plane. Okay. If M is the mass of the object, then the weight of the object, which is equal to mass multiplied with gravity. Okay, that is the weight of the object, mg, that will act exactly downward. Okay, weight is the force exerted by the object to the surface. Okay, then we can say the surface will exert equal and opposite reaction force to this weight. Okay, that is the reaction force which is acting exactly upwards. Okay, that is the reaction force. Okay, here this is when the object is in rest. Okay, here Under the action of an applied force towards left side, the object tends to be moved in the left side direction. So here I am going to apply an external force towards left side. Okay, this is the external force applied on the left side direction. Okay, when this force is applied on left side, tends to move the body towards left side, then in the opposite direction, the frictional force F, okay, that will arise, which is numerically equal to the product of coefficient of friction between the sliding surfaces of the object and the rough horizontal plane, okay, multiplied with or the normal reaction. Okay, in case if this F, that means the applied force on the left side, overcomes the frictional force, then the object will move towards left side. Okay, then this will be the direction of motion. Okay, when the object moves towards left side, then the inertia force, numerically mass multiplied with the acceleration, okay, that will act opposite to the direction of motion. Okay, here due to the net force capital F minus FF, the object moves towards left side, so the direction of motion is towards left side, so the inertia force will act towards right side. Okay, so the analysis, summation of vertical forces equal to 0 here, or the reaction force is an upward force weight which is equal to mg, that is an downward force, so we can write upward force or that equal to the downward force mg. Okay, and we know that ff that equal to mu r, further we can write r equal to mg, so this equal to mu multiplied with mg. Okay, then summation of horizontal forces equal to 0, that means capital F minus FF, that equal to the inertia force, algebraic sum of the external forces that equal to the inertia force. Okay, in case here we can substitute ff equal to mu mg. Okay, we can write f minus mu mg, that equal to ma, then we can write f equal to ma plus mu mg. Okay, these are all the further simplification. If you take mass outside, then we can write acceleration plus mu multiplied with g, like that we can write. Okay, so further simplification we can do as our convenience. And then here you can see, if here we considered this is the motion over the rough horizontal surface, in case if the object moves over a smooth surface, okay, moves over smooth surface, then the value of mu equal to 0. So the previous equation f equal m a plus mu g, if mu equal to 0, then this term will be eliminated, so we can write f equal to ma. Okay, this means this will be for the analysis on the object moves over a smooth surface. Okay, the next case, motion of an object, that means of a connected body in the vertical direction. Okay. Here, the object which is shown in the diagram, it is a connected body which is connected by using a string or thread. Okay. That means it's not a free fall. It is a connected body. The body connected with a string, thread, or wire, whatever. And then it's freely hanging. Okay. Here there are two cases. The first case, object moves upwards. Okay. Here you can see when the object is freely hanging. Okay. When it is connected by using a string or thread or wire and it's a freely hanging, the tension of the object that will act vertically upward, and then the weight of the object, which is numerically equal to mg, that will act exactly downward. Okay. If the tension which acts on the body, that is greater than weight of the body, then the object will move towards upward. Okay. That means this will be the direction of motion. Okay. This will be the direction of motion. Okay. When the tension in the string, that is more than the weight of the object, okay, then the object will move towards upward. As usual, the inertia force, that is m multiplied with a, mass into acceleration, that will act always opposite to the direction of motion. Then the inertia force will act exactly downward. Okay. So here there is no horizontal forces. And then here you can see there is no point of contact or surface contact between the object to the any other surfaces. It's a freely hanging. So here there is no possibility for the frictional force. Okay. When you take summation of vertical forces equal to 0, we can write the upward force T, that equal to ma plus mg. So we can write T equal, if you take ms outside, a plus g. Okay. So the tension equal to mass multiplied with acceleration plus g. Okay. This is for this case. Okay. Next, the case B. Objects moves downwards. Okay, the case B, object moves downwards. Okay, so here is the same, a connected body, it's freely hanging, which is connected by using a string, rope, or wire, whatever. So the tension that will act exactly upward, weight of the object, mg, that will act exactly downward. Okay, here the upward force is less than the weight. Otherwise, the downward force, mg, is greater than the tension in the string. Okay. Then the object will move downwards. Okay. The object will move downwards. So the direction of motion, that will be downwards. Okay. When the object moves downwards, we know that the inertia force, that is mass multiplied with the acceleration, that will act exactly upward. Okay, that will act exactly upward. So we can write summation of the vertical forces equal to 0. So T plus ma, that equal to the downward force mg, or we can write T equal mg minus ma, or otherwise T equal to m multiplied with G minus A. Okay. So this is the analysis, that is D'Alembert's analysis for the case B when the object moves downwards. Okay. The last topic, motion of object on a rough inclined plane. Okay. Here, three cases we are going to discuss. Case A, object slides upwards under the action of an applied force. Okay. Here, an object is lying on a rough inclined plane. Okay. We know that the mg that will act always exactly downward. Okay. Here, the theta is the angle of inclination of the rough horizontal plane with respect to the horizontal. Here you can see under the action of an applied force, that force is applied towards upward. So if it is the rough surface, the force of friction that will act downward, that means downward, sliding downwards. Okay. That force of friction, I just put it here. Okay. The force of friction will act downward. Here you can see this mg, that is a vertically downward force for the horizontal surface. But for the reference inclined surface, this mg is an inclined force. Okay. So here you can see this right angle triangle. If this is theta, this is 90, this will become 90 minus theta. Okay. So this mg, inclined force, we will resolve into two components with respect to the reference inclined surface. This vertical component will be mg sine 90 minus theta. But 90 minus theta, sine 90 minus theta will become cos theta. So the vertical component will become mg cos theta. Okay. Then the horizontal component of the resolved component of mg, that will be mg cos 90 minus theta. Cos 90 minus theta will become sin theta. So here the horizontal becomes sin theta because it is the angle is here 90 minus theta. Cos 90 minus theta will become sin theta. The vertical component mg sin 90 minus theta will become cos theta. Okay. So these are all the forces act on the surface. And then here you can see here mg cos theta, it's a normal force or the force exerted by the object to the surface. So equal and opposite force will be exerted by the surface to the object, that is normal reaction. Okay. So here the analysis, summation of vertical forces equal to 0. So we can write the upward force R, that equal to mg cos theta. And then we know that capital F suffix F, that equal to mu R. So we can write capital F suffix F, that equal to mu mg cos theta. Okay. Then the summation of horizontal forces equal to 0. Okay. With respect to the reference to the plane, horizontal plane. Here F is a right side force. mg sin theta and ff. These two are in towards left side. Okay. Here you can see under the action of the applied force F, if this object moves towards upward. Okay, that means if this is the direction of motion, okay, if this is the direction of motion, then the inertia force ma, that will act opposite to the direction of motion. Okay, so for the horizontal force, that also we have to consider. So here, capital F towards right side, that equal to mg sin theta plus ff plus ma. Okay, so this further we can write capital F minus ff, that equal to mg sin theta plus ma. Okay, so we can write f minus ff, that equal to m into g sin theta plus acceleration. Like that, we can write one simplification. Or for ff, if you substitute mu mg cos theta, from that you can write one so that means simplification, and then from this we can get the value of ga, like that. That are all the different things. Okay, so this is the analysis of D'Alembert's principle for motion of an object on a rough inclined plane, and the case A, object slides upwards under the action of an applied force. Okay, then case B, object slides downwards without any applied force. Okay, here you can see, to move the object upwards over an inclined plane, definitely we need an external force. But the object will slide downwards even without the action of any applied force when the angle of inclination is greater than the angle of repose. Okay, so in this case, if this angle of inclination theta is more than the angle of repose, due to the horizontal component of the weight mg sin theta itself, the object will slide downwards. Okay, so that consideration here we are going to consider. Okay, here you can see, as usual, the weight of the object mg, that will act exactly downward. If this is theta, in the small right angle triangle, we know that this will be 90 minus theta. So this, for the reference plane, this mg, that will be an inclined force with an angle 90 minus theta. So this I am going to resolve into two component. The vertical component, that will be mg sine 90 minus theta, but sine 90 minus theta will become cos theta. The horizontal component, cos 90 minus theta, but cos 90 minus theta will become sine theta. Okay, here there is no external force. And then the upward, here mg cos theta, that is the normal force exerted by object to the surface. So equal and opposite normal force exerted by the surface to the object, that will be reaction force. Or here you can see, when the angle of inclination of the reference plane is greater than the angle of repose, due to the mg sin theta, the object will slide downwards. So the frictional force ff, that will act towards upward, and mg sin theta minus ff, that is in this direction. That means this is the direction of motion. Then we can take the inertia force MA that will act opposite to the direction of motion. Okay. So these are all the forces acting on this inclined surface or inclined object. So here, the first analysis, summation of vertical forces equal to 0. So we can write R that equal to mg cos theta. Okay, so R equal mg cos theta. Then summation, then once you know R, then we can write FF, frictional force, mu multiplied with R. So we can write mu mg cos theta. Then summation of horizontal forces equal to 0. Okay, that means we can write horizontal forces mg sin theta towards left side that equal to force of friction plus ma. Okay, or if we keep this that side, we can write ff plus ma minus mg sin theta that equal to 0. So here we can substitute the value of ff, mu mg cos theta, then further simplifications and all we can do as per our convenient. Here, in both the cases, we considered the surface is a rough surface. In case if it is a smooth surface, on both the cases, the force of friction, FF, that will be eliminated. Do you understand? In both the cases, if it is smooth surface, then the frictional force we don't want to consider. Okay. Here, the last case, object slides downwards under the action of an applied force. Here, the angle of inclination is less than angle of repose. So, at normal condition, the object will not slide downward due to its own horizontal component of weight. That is, due to mg sin theta, it will not slide down. Okay. We need an additional applied force to move the object downwards. Okay. So here, an object of mass m lying on a rough horizontal surface. Okay. And then here, the weight of the object mg that will act exactly downward. If this is theta, we know this angle that will be 90 minus theta. Okay. So for the reference plane, this mg that will be an inclined force with the angle of inclination 90 minus theta. Okay. So we have to resolve this into two component. This will be mg sine 90 minus theta, but sine 90 minus theta will become cos theta. That is a vertical component. And the horizontal component, that is mg cos theta, but cos 90 minus theta. Here the angle is 90 minus theta. It will become mg sin theta. In case the angle of repose is less than angle of inclination, due to this component mg sin theta itself, the object slides downwards. But here, angle of inclination is less than angle of repose. So due to this mg sin theta, the object will not slide downwards. Okay. So we are going to apply additional external force to the object in downward direction. So now the object moves downward. And here, the mg cos theta, that is the vertical downward force exerted by the object to the surface. So equal and opposite force normal reaction exerted by the surface to the object. And when we apply the external force F due to F and mg sine theta, now this object slides downwards. So the frictional force F that will act upwards. So if this is the direction of motion, then the inertia force mass into acceleration that will act opposite to this direction. Okay. Then we are going to analyze. First, summation of the vertical forces equals 0. We know that the upward force R that equal to mg cos theta. Okay. Then we know that the frictional force FF that equal to mu R. So we can write mu mg cos theta. Then summation of horizontal forces equal to 0. Okay. So we can write the left side forces, external force F plus mg sine theta that equal to the right side forces, force of friction FF plus MA. Okay. So we can further simplify F plus mg sine theta minus FF minus MA that equal to 0. That means F external force mg sine theta minus FF mu mg cos theta minus m that equal to 0. Then further we can write F, if you take m in all the three terms, here it is MA. Okay. As common, then we will get m into g sine theta minus mu g cos theta minus a that equal to 0. Okay. In case here the surface is not an incline, then we have to remove the FF. That means this mu g cos theta, the term will be eliminated when this is same case, same condition on a smooth surface instead of a rough inclined subplane. Okay. So here, as of now, we considered three cases: motion of object on a rough horizontal plane, then the connected body on the vertical direction, then motion of object on a rough inclined plane. Okay. So these are all the overview of the D'Alembert's principle. Okay. I hope you all understand this video. Okay. So more number of numerical example on this topic based upon Newton's law of motion or D'Alembert's principle, we are going to analyze in further upcoming videos. Okay. To watch more videos, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Thank you guys. Thanks for watching.